where to go next. Sometimes it's just handling incoming data or sending data out. And similarly, the models is taken from model view controller, because the models.py is where we basically do all the work to talk to the database, whether it is storing stuff in the database or retrieving stuff in the database. We use the Django model capability to implement the concept in model view controller of models. So just a quick summary. I like to think of urls.py and some of the views.py as the controller. The models, of course, is all the things that talk to the database. And then the views are like the second half of views.py. So produced using templates and forms.py and et cetera, to produce the output and send it out. And so that's how I map the model view controller onto the Django architecture. And again, Django architecture was probably inspired by the model view controller, and that's why it takes some of its names of some of its capabilities from the model view controller concept. So now we're going to start producing the actual output of our application in the views and using templates. And there's a lot to cover here. So up till now, we've been starting to talk about URLs, which are simple. It says when you get the request with a URL of this format, choose a view and send it to that view. We're going to talk a lot about views.py and templates. In an upcoming lecture, we'll talk about forms. And we spent a bunch of time talking about models.py and how the models can talk to Python code, talk to the shell, how the models can inform how we write to the database and how we read from the database. So we're starting to fill parts in. As we put the views together, we're really starting to create our entire application. And I know it's taken a while to get to the point where we can update get to the point where we see the whole thing. So I just want to say that from time to time, wherever you have DJ free samples, whether it's on your laptop or whether it's on Python Anywhere, you should do a git pull from time to time, because I'm always working on these samples and I want you to make sure you have the latest copies of these samples. Sometimes I add little bits I don't change the samples, but I add bits of documentation as I'm like, ooh, I should have added that. So views are like the core of the application. I mean, the URLs find their way to views. Models tend to serve the needs of views, act as this layer to allow views to write and read the database. And so the views.py has a model aspect in that it handles incoming data. When we get to forms and post data, then we copy that into the database. The views.py decides sometimes whether or not to send the user to a different screen, or if it's going to produce the actual screen, the HTML, it produces that HTML, often using a template, and then sends it back. So the views are where the work really gets done. And what you see is you write a lot of code in the views. You write one line in the URL, a few lines in the models file, and then lots of stuff in the views. And I consider the templates kind of part of the views as well. So the first thing that Django does when it receives an incoming document, a request for a document, it basically parses that URL. And the first thing after the domain name is generally the application. So remember that Django has a project, and then underneath that there's one or more applications. In each of the DJ free samples, you see lots of applications, each application kind of to show a little bit of sample code for a topic. And so that second part of the URL, that is the application name, and for all intents and purposes, it's also the folder name within the Django project. Now within that, usually the next chunk is the view. And so that view within application, the view within application is defined in urls.py. And then after that, there are two kinds of parameters. One is like a key value parameter that comes after a question mark. It also uses ampersands for that. And then sometimes we just put after slashes. This is more of a REST style URL that's very pretty, and you put the parameters right on the URL rather than the question mark, which is sort of the old school for doing all this stuff. So there is this thing in Django called the URL dispatcher. I sort of call it router on my picture. It's basically to get you to be able to define the URLs and how those URLs are to be parsed and handled, and how those URLs to be routed to the various bits of view code. And so we do this in urls.py. There are three basic patterns. First, you might route a particular URL pattern to a predefined class, and you'll see the example of that coming up. Or there's sort of functions, really old school function that take this request, which is an object that captures all of the data, the parameters, the URL, whether it was a secure request or not, what host it came from, what's the IP address it came from. All that stuff is wrapped up into this request object, which we'll talk about in a second. And that view function looks at that request object, decides what to do, talks to the database, maybe, and then sends back a response, whether it's a redirect or some HTML. And the function is kind of the low-level thing, but you can also then define a class. And defining classes, as we'll see, is really quite nice. The classes have methods like for get and for post, depending on the kind of incoming HTTP request that we're handling. And it also, in those methods, the request and any other URL parameters can also be sent in. So let's take a look at a sample urls.py from views. And we see examples of all three kinds of these routes. URL patterns is a global variable. It's just a list, but it has very special meaning. This list has very special meaning to Django. And you see these path commands, and there's other ways to describe these things. And then you have the path, and the blank path means sort of just slash right after the application name. And then we have which view to send it to. And so this template view as view, this is basically to save you from writing code if all you want to do is take a template out of the templates folder and return it. So you don't have to write your own code in views.py. And so it's already there, and that's why we go into Django Views Generic Import Template View, and we're going to say, you know what, I'm going to route, I wrote that template, but I just don't want to write the code to go send that, just read that template and send it back. And so this is a predefined bit of Django that does this for us. Sort of the more old school thing is this syntax right here. And basically from .import views pulls in views/views.py. And then this, you will see our functions inside there. And then these are classes also from our views.py for this particular application. And the syntax is a little weird. This is the module we imported. This is the class from that. And then as view is a static method that returns a function that then can respond to the incoming requests. And we'll see these as we kind of go through these. So up next, we're going to actually look at the views.py and take a look at the views. So now we're going to take a look at the code that actually writes the views, the code effectively in views.py. Now the first view that we're going to take a look at is one where we're not even writing any code at all, and this is that predefined view, that template view. And again, template view is code that a class that's given to us from Django, template view, and you pass it a parameter. So we're actually kind of calling a function here and passing a template name to it, and that is a file, views main.html. So this is the application views, there's a subfolder called templates, and then I'll talk about this in a bit. We repeat the application name twice, so that's a little bit weird, but it has to do with the fact that these names are global across all of the applications, and so you want there to be possibly more than one main.html, and so that's why you have this extra folder name, and you put this there, even though that feels a little bit redundant, but it's okay. And so this is just a static HTML file. I'm not going to read any data from a database. I'm not going to write any data to the database. I'm just going to read this file and send it back to the browser. And that's a common thing where we just have a file that we want to send back to the browser. And so we just don't even have to write any Python code other than add this entry into the URL patterns in urls.py. So that's a view where you wrote no Python code. Now, for the parts where you're going to write Python code for a view, you're going to be passed in variables. The variables are all about the request object. The request object is all the data coming in, and the response object is something you produce in the view and you send it all back. So the request object is an object instance of class HTTP request. This is a predefined Django, and there's just a whole bunch of things. The scheme. Now, what is the scheme? Whether or not it's secure or insecure HTTPS. The body, it's a string. So there's like about 20 or 30 attributes. We're going to use some of them, but you don't have to use all of them. But you can go look up the documentation, and the more sophisticated your application becomes, the more likely you're going to have to go digging in to find some little bit of the incoming request. You could think of this request data as all that data you see in your browser debugger about what data was sent to the server. That all ends up somewhere in this object. Now, when we return from a view, we have to send a response back. And so the response is something that we create inside of our view. It might be simply text that's HTML, or it might be a redirect object, redirect response that says, hey, go to a different page. And so we make that the main job at the end of the view is to produce a response and then return it back to Django. And so here is a very simple view. So here we're saying, we're in the views application. We're going to go to the view funky, right? And so in the URLs py, we say map/funky to this function named funky. It's a funky function. That's why I call it funky. And so when it sees this, all the data coming into the request shows up in this variable that is the first parameter sent to that function. So that's what this is saying in urls.py. Take everything that goes to views/funky, gather up all the request data from the browser, put it in an object, and then pass that request object in. Now in this, I'm not really going to do anything with that request object because I'm always returning the exact same thing. And so I just have a nice triple quoted string of some HTML with less thans and greater thans, and I'm going to basically return. It is my job in the view to give back a response. There's a couple, two main types of them. One is an HTTP response, which is just like a body of text, and that's what I'm sending here. I'm sending an HTTP response. That's a constructor. We're constructing a HTTP response object and taking that string that I put in there, and away we go. Okay? And so that basically, if you hit this path, you're going to get this page back, and it sort of looks like that when it's all said and done. Okay, so now we want to talk about how we can get at parameters. So I mentioned that this request object that comes in to your view function has all the data from the request. Well, if we send to a view with this question mark, key value pairs, that's guess equals 42 on there, and we're going to route danger to views.danger and urls.py, and so all this data is wrapped up in this variable called request, passed into the function named danger. And so inside of request is some data. Request.get is a dictionary of the key value pairs that are on that URL. So to pull the 42 out, we can say request.get bracket quote guess quote, and that pulls that out. And so that's all we've got here is a really simple HTML page, and we are replacing that little chunk with 42. And so whatever this number is comes back out in the output. So your guess was 42. So that's how we pass get data into a view. Now, up next, I'm going to explain to you exactly why it is I called that function danger. So it's important from time to time to talk about ways that you as a web application developer have a responsibility to create secure web applications. And so I want to call your attention to places where you write code that seems like on the surface that it's what could go wrong, and then you realize, oh, wait a sec, that could go wrong. So it turns out that you take data from the user in the request object, whether it's from a form or from the URL, and, like guess equals 42 seems innocuous enough. And then what I did is I just concatenated that into HTML and I sent that back. And so the problem is what if somebody with ill intent tries to produce data that actually does something? And the problem is if I take data straight from the user and put it back in the HTML response, well, HTML and JavaScript are programming language. Your browser is being programmed, and that means that a user typing data into your system can program the browser. And what's even worse is that, having them program their own browser, not such a big deal. But in a way, what they do is they put some data in your system that turns into code, and then they kidnap someone else's browser when they take a look at data that came in. This is called cross-site scripting, where in a sense what it's doing is it's trying to run code so that it can read stuff from your site and then hand it to a rogue site. And so we have to protect against this, and it's a very simple thing. So if we take a look at the code that was bad, basically we have this parameter guess, and in the last time I showed you that was 42. And we just took this request get guess, which is this stuff, and we simply concatenated it into some HTML. Well, if I carefully construct my guess with %C3, blah, 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 all the blah, 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 all that stuff, well, that turns into, this is a URL encoding of less than, B, bold, greater than, bold, slash, so that turns into HTML. So I passed into this application some HTML, and I as the developer took that and I concatenated it together, so the response source has HTML. It's HTML that mostly comes from the application, but this little bit of HTML came from the person who put it in. And like I said, it's not such a critical problem if I, in my browser, put stuff to take over your browser, but it is if someone, you can move that into someone else's browser. So what happens is the browser sees this bold text in HTML, and instead of showing us the less than and the greater than, it actually shows it to us as bold. Now this seems innocuous enough until you do something much more clever, and that is I am going to carefully construct some code, JavaScript. And so what happens is this here is encoding of that line right there, the script alert owned / script. And so what happens is that came in and it was concatenated straight out. And if you run this page, you won't see the data, but actually JavaScript will run, and it's going to show up an alert box that says owned and OK. Now, you can go ahead and look at the Wikipedia entries on cross-site scripting. Generally, the idea is once you're in JavaScript, you don't just say alert that I've owned your browser. What you do is you do something like grab a cookie and send it to a third party, or you call, say, a web service on the system with a cookie and do bad things. Like you can convince a teacher to log in and change someone else's grade or delete all the grades in a class. Once you're into a person's browser in JavaScript, you can do a lot. So that's really quite scary, and there's all kinds of scenarios where you're taking data from the user, and you got to be careful because, yes, I said the guess is supposed to be a number, but if it's not a number, if I concatenate it without escaping it, it's a problem. So here is a safer version of that. So I've got another view function called game, and it takes that same request, and it still pulls that get data off, which is this bit right here, but then it calls a function, and that's Django utils HTML escape, right? So what that does is that concatenates that into the HTML, but escape processes any dangerous characters and turns them into what are called HTML entities. So less than becomes ampersand LT, greater than becomes ampersand GT, right? These four things with ampersands are a safer version of it. And so that means that even though I put in the data for bold, it comes out with the less thans and greater than showing, and it's not actually interpreted, right? So this whole notion of escaping, or HTML entities, converting data, running the data from a user through an HTML entity's automatic filter, ensures that the user cannot provide you data that turns into code in their or someone else's browser eventually. So that's the kind of thing you have to think of as you're concatenating stuff together. And the key thing is the request get guess, that came from the user. And so we think the user's going to be nice, but a user with bad intent can send data that they carefully construct to cause them maximum trouble. But if you just escape your data before you concatenate it, there's nothing they can do about it. So another of the views is where we're going to parse the parameter off of the URL itself. These URLs are a little prettier sometimes than the question mark keyword equals value. And so, so let's take a look at this. The way you do this is in your URL patterns, you have a path, and instead of just having the path name, the view function name, you actually have this bracket, int colon bracket, guess bracket. And what that is, and you can go look this up in the Django documentation, there's a whole series of these things, that says the parameter after the word rest is an integer, and please pass it in as the parameter guess. So I've chosen the name to pass it in as a parameter, and then once Django sees this, it pulls that 41 off and hands it to us. So we don't have to tear the URL apart. Actually, in this request object, we do get the URL. We could do a bunch of splits and fool around, but nah, doesn't matter. Let's let Django do all that work. Let's just tell it we want that parameter after the word rest. It's supposed to be an integer, and pass it to me in the variable guess. And then that same 41 comes in. I am cleverly escaping it before I concatenate it, and then I return a text-based HTML response with some HTML back to the browser. So this escape is there just because of cross-site scripting. I'm still taking this value, still coming from the user. So if any value comes from the user, you have to properly escape it before you show it to them. Now, those are all function-based, which are sort of a lower level. We haven't got to the point where we're talking about forms, but eventually in those lower level functions, you have to check whether you got a get request or a post request. Post request often comes from forms. And so this class-based view allows us to give a method for get and a method for post, and let Django pick whether it's a get or a post. And this is an object, and if you're a little rusty on objects, I've got a URL there on pythonforeverybody.com to review just like what a self is. I'm not going to cover all that. In the path command, you just have a string that comes after the application, routing to this. The main view, as view, is something you got to add to it because main view is a class, not a function, but as view is a function. And then we have to create a method get. Self, of course, is just part of Python's object-oriented work. Request is that first parameter, right? And so this one here is just a stock response, and just like the other ones, I return an HTTP response. Now it's like, why this looks a little more complex than the other one. Did the same thing, but it turns out there is tons of things that we can do. And inheritance, the fact it's a class, there are so many things about object-oriented programming that over the next few lectures we're going to really take advantage of this, and we ultimately will rarely write the old school function-based view. We'll do class-based views. And so we can also pass parameters to class-based views just like we can pass them to function-based views. You say, okay, with a prefix of remain, slug is a kind of string, and then guess is the parameter, so that says pull the string after the word remain off, right? Views is the name of the view, remain is the view within the application, and then this third parameter is the guess, and it's automatically parsed and handed to us in guess. And then we're going to respond to a GET request. Self, of course, is the object-oriented thing. Here's the whole request, and guess is that little piece that comes off of the end of the URL. We're going to create a response by escaping the user-provided guess bit, so that if the user puts something nasty in for cross-site scripting, we stop them from doing that. And so that produces the same kind of output. Your guess was ABC 12342 XY ZZY. So, talking about return values, everything we've shown you up till now is your basic 200 OK, which means you asked for a page, I gave you a page. You're probably familiar with 404 not found, which means you asked for a page, that page doesn't exist. There is another kind of response that's not actually a page, which is a response header that says, you know what? It's not like you made a mistake, but you're at the wrong place. And we call it a redirect, and 302 means I know where you're supposed to be and it isn't here. And it was originally used for sites that would move. And it's all handled by the location header on the HTTP response. And so we send a redirect response, which is a 302 with the location header being set, and it uses our URL. And when the browser gets that the 302 and a location header, it doesn't show you what it just got, but it immediately re-gets that URL and then shows you that URL. And the original idea was that if you renamed a domain or something, you wanted to have the old domain redirect web browsers and search engines, you use these 302s. There's also a 301 header that can be used to redirect all this stuff. But now we use it for all kinds of things, and it's very much a controller function. If you go to Model View Controller, controller says, okay, we're done with that, but I want your browser to go over there. So that routing, that sort of routing the browser, changing the browser, putting the browser where you want it to be, that's part of the application's controller phase. So we can send a redirect from a Django view. And so here we go. If you go to this bounce, it's going to actually not end up at this. It's going to bounce it to somewhere else. And in the path, we just say if we go to the bounce view, run to this function. This is not a class-based function. This is an old school function. And so the request data is passed in. And instead of now returning an HTTP response, which we would put in here HTML, we are doing an HTTP response redirect, and now we put a URL. And what we're saying with this whole thing is, you're at the wrong place, please browser, when you get this response back, go here. So it's like it bounces to the browser and then bounces back and then reads that URL. So, and you can have some output, but folks generally don't need output when you're doing a redirect. So if you take a look at that bounce, watching it in your network console in a JavaScript debugger, what you see is you see a set of 3 requests, actually just 2. You'll see the first request is going to bounce, and if we take a look at this request, we see that it's a 302, it's kind of small. You see we got a 302, which tells the browser something's wrong, I'm not at the right place, and then also the server sends the location header that says this is where you're supposed to be, and the browser immediately turns around and does a get to that URL, simple.htm, and then that's what we see. And then this 404, interestingly, the 3 statuses I talked to you about, is because at this new location, djfree.com/simple.htm, there's no favicon. Remember, the favicon is the thing that shows up like right there in the top tab bars, the favicon. And I don't have a favicon, at least not now for DJ Free. I should put a favicon there. But we get to see a 404, and all that means is the browser looked for a favicon and didn't find it. So we see a 302, which is moved with a location header, and then we see a get, which returns then a 200, which is a success, and we see the document, and then we see a 404 because it tries to grab the favicon. And so the HTML you get back from djfree.com simple.htm, that's this simple page with a simple link. Okay, so that's how the redirect works. So that's a series of views, both the input, class-based, function-based, and to both the HTTP response and the HTTP redirect response. So up next we're going to talk about how building templates makes us do a lot less concatenation. Hello, now we're going to talk about the other half of the views, the templates. And the templates are our way of creating HTML. And again, just to ground everything that we've got here, we're in the views, and the views are really sort of the code, the Python code that we drive. We're going to get to forms in a bit, but views kind of merge stuff from the templates, merge stuff from the models, send stuff in and make pages, right? So this is going to look a lot like HTML. It doesn't have to be HTML. It can be things, but other than HTML. But templates in our class will mostly be HTML. And so they're kind of the last little piece of the puzzle to start building user interfaces. And from this point on, we're going to be making user interfaces rather than introducing the parts of a Django application that have the user interface. So this is the text from the Django website. It's about convenient ways to generate HTML dynamically, and there's a couple of different templating engines. We're using the default one, and there is some data that we pass into the template. There's a process that's called rendering, and then we get the HTML back, and we return to the browser with that HTTP response, which we've already been doing. It's not the request response cycle is the same. The difference is, instead of writing Python code to concatenate a bunch of things together, we are going to use a template engine. So this is the kind of stuff that we've been doing all along. We have a class in a view class, REST main view that extends this view. In comes perhaps the request object, and then maybe even another parameter. That's not changing. What we're doing here is we're using concatenation. Concatenation, these little plus signs. Escaping, we're doing all the escaping and concatenating, and then we are sending back a response. So what goes back as a response, what comes in as a request, what goes back as a response. We're still going to do that. We're just going to get rid of that middle bit and make it a little prettier and make it a little more sense. If you look at that, if you look at it, you got to get it syntactically right. You got indentation problems. That's 3 lines of Python. I'm using triple quotes. I'm using plus. I got to get all that matching together. And then, eventually, I'm going to be in the HTML is going back. I'll be using single quotes and double quotes and all those kinds of things. And JavaScript's going to look really ugly here. Indenting of the HTML kind of will fight with the indenting of the Python. So this is just general. I mean, I've only done short ones because I only wanted to show you a little bit before we showed you templates. So the basic process is a bit of software, a template software that Django provides us. We're using the built-in Django one. And basically template is some HTML with some hotspots in it that says put data here. And then the rest of it is just HTML. And then we pass the data in some kind of an object, dictionary, etc. And then a bit of code pulls all that stuff together and then produces the HTML with all of the data placed in it. Often the render data that we're passing in is coming from a model, for example. We might talk to a database, load up a bunch of rows, and then put it in. But in the simplest form, what we've got is like a little dictionary. Call this the context. You could call it the render data, and then you have the render template. So the render template is really HTML, and that's what makes it a lot easier to look at because you're not putting double quotes around anything. There's no concatenation, but there are special characters. And what the double curly brace surrounding it says is, instead of that, take this bit out and replace it with whatever's in the variable dat from the render data. And so that's how, when it's all said and done, this is replaced in the fun stuff, replaces curly brace dat in the final output. And if you thought about it for a while, you could probably write a render engine. They're not that hard. Now you'll see they have some sophisticated features eventually, so you probably don't want to write your own render engine. But you could imagine a Python assignment where I say, write me a function that takes a dictionary that looks like that, and then with key value dat fun stuff, and then take some text file that has curly brace dat curly brace, and then find that and then replace it with that string. You could write that code. You don't want to write that code. Django has already written that code for you. So here's the code in action. And so this is, we're going to call this, we're in the application named TMPL, Temple. And so we have the application temple, we have the view game, and then we have a number 200, and that's what we put in our urls.py to route the game view and take one parameter. Remember that slugs are a special version of strings that are letters, numbers, and dashes, I believe. And so the entire request coming in from the browser is coming into the variable request. This number 200 is coming in the variable from the URL is coming in the variable guess. And so instead of us concatenating together, we are going to create a context. What I call a context, which just is a dictionary of key value pairs. And the key for guess is GUESS. It's a string. That guess will matter inside the template. And then we pull this number 200 and we convert it to an integer, and then we pass it in. And this render, we pass it the request object, we pass it the name of a template, and then we pass the context, the key value pairs, to be substituted in that. So let's take a look. So if we look at this template, it has a series of curly brace, like hotspots, places where you would replace stuff. And so the double curly brace just says retrieve the string that is under guess and put it in. And so that's how we get your guess was 200 in the ultimate output. And then we have curly brace percent all the way to percent curly brace. And this is a series of if then else's. So you can put logic in here too. You don't have to just take this string and put it in. So what we're doing is we're basically saying if the guess is less than 42, we print out too low. If it's above 42, we print too high. And of course, if it is 42, we print out just right. And since our guess was 200, it prints out too high. And so basically, this makes this view code a lot simpler and doesn't put a less thans and greater thans and concatenations. It's all substituted by this render routine. Now, the render routine returns an HTTP response request. So when we get that back, we just return it. So we hand back to Django the HTTP response request, and then the page is displayed in our browser. Remember that we have a Django project, and this is the Django project. In my case, the Django project is DJ for samples, and I have a bunch of little applications. All these things, as a matter of fact, Temple is the one we're working at right now. Those are just the different pieces of sample source code that I built for this class to talk about. And so those are applications. So it's just that Django terminology. Project made up of one or more applications and folders. Okay? And so the problem is these templates, when Django starts up, based on the settings.py, it loads all these files up. Loads them all up. And so it loads them all up, and the templates are actually global, and we'll see this in a bit. They're global across all of the applications. And so the problem is that if you have a template name like detail.html and you have a whole bunch of applications like I do, all of which want to have a template named detail.html, it doesn't work because which detail.html, it'd be template/detail in two folders. It's not clear which one you're talking about. So we've adopted a convention that we take the application name and we make a subfolder inside of templates. That's the application name. And then we use this favs/detail.html or pics/detail.html as the name of the template. So in a sense, we're introducing a subfolder. It's a little jarring at first because you see there it's the same. It's a good convention. I mean, it's unfortunate we have to have the convention, but because these names end up being global across your entire Django project, in each application, and to get them a name, to get them properly named, it's necessary to introduce this extra level of redirection. And when we get to logins, there's templates that are stored outside in other applications. So sometimes you want to get a template in some other application. So there's all kind of reasons. This is a great idea. It just isn't the prettiest thing in the world. So just when you see it, don't freak out. I try to call it out in the slides. And so we put these paths that includes the application name twice. It's weird, but it is necessary to do this because of the notion that all these template names are global across the entire application. But if then we call this the template name with the name of the application prefixed, away it goes. Django could have made that a little easier for us, but they basically didn't, and so we have to do this. But everybody does it the same way. So now what I want to talk about is the actual templating language itself. I showed you a couple examples, the double curly braces, but it turns out there are lots of things that you can do with double curly braces in the template language. So now we're going to talk about the actual template language. As I mentioned before, there's more than one templating language. We're using the default one, and I think it's actually one of the better ones. This whole notion of double curly braces. There's all kind of templating engines, and a lot of them use these double curly braces. Sometimes there's a one called mustache because the curly braces look like a mustache. So this double curly braces, you learn it in Django, and you'll find it all kinds of other places. I've used it in front-end processing. This is back-end processing because we're doing all the substitution in the back-end. So there's basically a couple things you can do. The double curly braces do substitution, and one thing that's cool about this, if you recall, I talked about how you have to escape data that came from the user. Anything in the double curly braces is automatically escaped. As a matter of fact, you have to do something to not escape it, because it turns out that 98% of the time you want to escape data that you're printing out, because it doesn't change what it looks like, but it does make sure that it's safe. If you add this vertical bar safe afterwards, that's like a modifier. I think it's called a filter in Django that says, look, don't run this, don't run that filter on it to do the HTML entities. Just do it as is. I know there may be HTML in that, but I've taken care of that because I am the application developer. You can call functions, like with the code is the percent, curly brace percent, and in there you tend to call a code. This is like code. This is like calling a method or a utility code. And so the first part of this is what you're calling, and then later you can have some parameters. So this URL says, I want to find a URL for the view cat detail, and I'm going to take the number that is the current cat primary key for the cat record and put that on as the URL as well. The author in this case is and we'll see this later, is a model item, and get absolute URL is a method inside that model item. You can have sort of ifs and if then else's. It's kind of Python-like, which is nice in that you don't really have to learn new things. There is looping code that's in there, like a for loop that we'll talk about in a bit. And then there is blocks that can be replaced. So you can have a template that sort of pulls in another template and then substitutes in part of it. So you can have whole blocks of substitution, not just little strings of substitution. And so we'll talk about each of these in turn. So here we go. We'll start with a real simple one. And you'll notice that in this particular simple one, we have no parameters on the command on the URL. So we don't have any parameters here. I'm going back to a non-class style, just a simple function, and I'm not sending a context. The context would be the third parameter on the render call, and so I'm just saying, hey, and this is what you do when you just have some static HTML that you don't really need to change anything, and so that's what's sitting in here. It's just a simple page. There's this thing called a built-in template view class that sort of does exactly this thing, that just grabs a template, turns it into an HTTP, grabs a file, turns it into an HTTP response, and sends it back to Django. So that's just a super simple template. Now here's one where we're going to take a parameter to the context, and I'm not taking it from the command line quite yet. I'm just going to make the parameter always be 42, and the key is, this is a key and this is a value. So zap in this case is the key and 42 is the value. I often call this variable context, but the fact that's just a mnemonic memory thing for me, context or CTX is what I tend to call it. And now I'm passing in the template, this template here, the guest.html template, and it has one little curly brace substitution, and remember that does escaping for us automatically, so there's no need to use escape the way there was when we were doing this via concatenation. That alone is a good reason to use templates. And so this ends up sending out your guess is 42. So this is just really focusing on what's in that context and how the things come out of the context. This name here, zap, in the context, means pull the thing out of the context under the string name zap, and then it substitutes the results, like the 42. So instead of it saying guess was zap, it's your guess is 42. So that's really focusing on the substitution. So this is showing us how we do the save stuff in case you actually want to pass some HTML into a template and actually want it to render as HTML, not as HTML entities or HTML entity style. So we're sending in a thing that's bold with a B and a less than B. That's HTML. It's got less thans and greater thans in it. And then we got zap. And so you can see that the zap comes out as 42. It's HTML entities, but it has no special characters. But if we escape text, text is the one with the HTML entity characters, that automatically escapes it so that you see the less thans and greater thans in the browser output. Escaped, less than B, bold, greater than B, right? And if you say text and then add the safe filter to the end of it, that says don't escape it. And so then this bold goes right into the HTML document, and instead of you seeing the less thans and greater thans, you're actually seeing the text turn to bold. Now, usually the bad folks that are trying to get into your computer are not just turning your text to bold, they're trying to run JavaScript. And all we're showing here is that whatever less thans and greater thans would be in that context value txt, they're going to end up literally in the document, and the browser is going to interpret them as HTML. I mean, there's just no way that somehow your browser knows the HTML that came from your program versus the HTML that came from a context variable, because by the time it gets to the browser, it's all one thing. And so it doesn't know, oh wow, that's dangerous. That came from a variable. No, by the time the response goes back to the browser, it's just a blob of text. Now we can talk about some loops here. I am passing in 2 arrays, apple, orange, banana, and lychee. And then I'm passing another array called n with peanut and cashew. And then I'm going to create a context. And in that context, I'm going to have fruits point at the list F, nuts point at the list N, and then zap is just the string 42. And do I even use zap in this one? No, I think there's another place that it. No, oh yeah, it's. I just don't have it in the. So here's the template, a part of the template. It's not looking at zap, and so here's the key. So we got this for loop, for x in fruits. Well, fruits is looking up something in the context under the key fruits. They're string. They don't look like strings in. They don't look like strings in the template, but it looks up there and it finds a list. So that little list F is what really is going on here, and F is a list of apple, orange, banana, lychee. And then X becomes the iteration variable. That's only within the template. And then I'm going to print it out, and then I'm going to end it. So that's like the start and end of a for loop. Apple, orange, banana, lychee. Now, you'll notice that I have an li tag, which is the list item tag, and it just generates all that HTML. And again, the double curly braces are doing HTML entity escaping automatically. So, so we take a look at nuts. So we ask, is nuts present? Because that's a way to tell if if variable's present or absent. If it's absent, I'm going to ask another filter on the end saying how long was it? Okay, and so this is the n. Nuts is the n list, and it has a length of 2, which means it has 2 elements in it, and so we see the number 2. And so you can do various things. So this is an if then else, the syntax of an if then else, with curly brace percent. Now we can pass objects within objects, and so it's a little tricky. We have a context in this x variable, and the sort of the outer key is pointing, the key is outer is pointing to another dictionary, and in that dictionary there is a key of inner with a value of 42, and then we render the nested.html, and you see the outer, but then outer dot inner, that's, so outer is that object, and then object dot inner, then this thing becomes 42. Okay, so you can kind of walk through objects if you have hierarchical objects that are objects that contain objects, or lists that contain objects, or any number of hierarchical structure of lists and objects, you can walk through them. So here's just another simple example. This one has data coming in instead of hard-coded. So we again have game 200, and we're running into game view. It's a class view, and the 200 comes in as the parameter because we said it's the parameter that comes after the word game. And so guess comes in as 200. It's a string at this point. It hasn't been converted to an integer. So when Django pulls these off, well, it does some validation based on the types, but it doesn't actually necessarily convert them. And so we're going to create a context, x equals a key of guess, and convert it to an integer to pass it in. And then we're going to pass the context in and the template in. And so the word guess is going to come out, and we sort of saw this. The guess is 200. And then depending on the if then else logic, it's going to say, in this case, too high because your guess was 200. And of course the right answer is always 42. So now we're going to talk a little bit about how you manage a common text going from one template to another through template inheritance. So now we're going to talk about a technique called template inheritance. And this and other times, it's a great time to review object-oriented programming, because I'm just going to use object-oriented programming definitions and words and not completely explain them. So you got to know what a class is, you know what self is, those kinds of things. And I've got a great online lesson that you can go read and listen to and understand objects, and I'll explain it to you in 30 or 40 minutes. So inheritance, actually from that lecture, is the notion in object-oriented programming to not repeat yourself. You have some kind of a shape, and then you make a bunch of objects that mirror that shape. But you can also, with inheritance, you can have a shape that makes another shape, like a shape in general that's a triangle. And so you can inherit that all triangles have everything shapes have, and all squares have everything shapes have, and all circles. And it's just a way of capturing information once, writing code once, and then not repeating yourself. Functions are a form of DRY, don't repeat yourself. Modules are, but inheritance is the key. And inheritance kind of can get in our way as programmers because it leads to smaller and smaller code. If we're going to make 5 things, each of these 5 things is really small because we make a big thing over here and we inherit all 5 of those things from it. But then you look at it and like, oh, I don't understand that, right? I don't understand these only one-line functions. What are they doing? Well, the answer is there's 50 lines out here that we're inheriting from. So we'll see some of that. I'll try to kind of allude to that part where, look, there's magic over there. And a lot of what you do in Django is use classes and objects that you didn't even create, meaning that they've got data in them like .scheme or request.scheme. And so this is just also a way of trying to simplify the way you handle sort of things, objects that are handed to you, and then you hand objects to other parts of Django. So template rendering basically says, okay, here's some rendered data and here's a template. What happens now is there's this thing called a base template, and the base template and the template combine together to be sort of like the ultimate template, and then you pass in the rendered data and produce the rendered output. So let's just say that we had a bunch of pages and we were doing the same thing over and over again. Now we will soon do this with navigation because you want to put a menu at the top of every page, and literally that menu could be 40 or 50 lines of HTML, and you do not want to repeat that menu every time at the top of the page. So you want to put that one place, and then you want to make many pages that have the same top navigation so that your pages, as you go between them, look like the navigation is the same. So we're going to do this in a very, very simple way. So we have one template, this cond.html that we've been playing with. You'll notice it has some HTML and a title and a body tag and some of this, and then it's got this stuff. Well, let's say we wanted a bunch of pages that had that everything but the body. So what we basically then do is we take parts of this, like the repeated parts, and we put it into a template. And then we take the part that we're going to change every time and we put it into a template that then extends. So see, this one here has one line that says extends temple-base.html. So this one uses everything in here but then adds some stuff. Okay, so the basic idea is we split this one big template into reusable parts and non-reusable parts. And then we have a bunch of templates that come off a base. We call it base commonly in object-oriented world because it's like the thing that we're basing it on. So, you know, this is the base, and then we're going to build on it. Base, build something else on top of it. So how this works in practice, we have a view here. We're going to call this view game2, right? So we're going to use the URL game2. We have a class-based view. We have a get method in there. The request data comes in as request. We told it to parse the slug off the end and pass it to us in the variable guess. We make a template, which is exactly what we did before, where we have a key of guess and the value is the actual guess itself. And then we pass that template in the variable x into render, and we tell it to go read temple_con2, which is the condition, the second conditional one. And the thing is there's nothing in the Python code in the views.py that knows about the base. What happens is the only place that the base is the only place that the base is noted is in the con2 template itself. It says, hey, go grab this one and extend it. Now the way it works is it starts out a little counterintuitive. It says it really says start with this template here and then push this content into the base template. And this block content and end block, it basically, that tells what I want to replace. You're replacing blocks in the base template. So all the stuff in the con2.html that is between the block and the end block is what is then pushed into the base template. And then in a sense, the base template with those blocks replaced is what is returned as a result of the render and then returned to Django as the HTTP response. We're going to use these a lot. When we start doing navigation, we're going to go crazy with these things. So up next, we want to talk about URL mapping and reversing, where we have to actually make a link in one page to a different page. So now we're going to take a quick look at URL mapping and URL reversing. This has to do with basically routing, and it really allows us to generate links from one page to another. So we're in the middle of a page and we want to make a link to a different page. We've got to figure out what the string of that is. So again, we're sitting here in the middle of our code. We're in the views, and this URL mapping is basically a set of functions that allow us to read the urls.py. In a way, if all these functions didn't exist that allowed us to read urls.py, we would write a bunch of functions to do that. And so these are just now part of Django. And so often these are used in the view. Sometimes they're actually used right inside urls.py to come up. So it's like, if you know the name of a view, what would be the URL to get to that view? And sometimes views have just a URL, and sometimes they're a URL plus a parameter, and that's all set up here. And so it's like, give me a link to a view, please. And then Django looks in the urls.py, potentially across applications, and gives you that string. And it's just to avoid hard coding the strings. That's really the idea. And so this is just a common problem. This is the documentation right from the Django website. You don't want to hard code these things. You actually can, but then if you rename an application, the whole idea is you could make a Django project that had 4 or 5 applications, and then you could reuse some of those in a different Django project and add some more applications. So, you know, you don't want these applications to have too many hard-coded decisions. And it might be easier to hard-code some of these things, but it is actually in the long run much easier from a maintenance perspective. And so it's better maintenance. It's another don't repeat yourself, or doing a table lookup rather than hard-coding strings. It also lets you hunt around in your code to see where it is that you're talking to that other application. Because we're going to do login eventually, and login is another place. It's not in our application, but our application is going to have to generate login URLs by asking the login application, hey, what's the URL to log in? What's the URL to log out? And that's where we'll mostly start doing this. So I want to talk about it now, so when we get to log in and log out, you'll have that will make more sense to you. And it also is some of the stuff that you're doing from the tutorials. you're putting these reverse lookup things in, and you may or may not know what they are. And my goal here is to give you a little sense of what really they're there for. So let's take a look at an example. So here we have our urls.py, and most of it, I mean, this is the application route. So if you're looking in the samples, it's in the route application. The main thing that we've added is some names. Names are here to look up these paths. We don't really want to look it up by this path mapping because that could actually change. So we're basically saying this view in your views.py, second view, is going to be referenceable by this second dash view. I named them differently very much on purpose. So here's what happens if you just go to the route/route, the name of my application. It pulls up this main/HTML. And so the first thing I want to show you is what a hard-coded URL looks like. Now we know that blah 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 samples/route/second is going to go to that second view because the application's name is route and the view name is second, and that's good. That will work. It's not going to break, but this is where you lose flexibility as you try to recombine applications from one into the other. And so in a sense, what we're asking to do here is we're going to instead use this URL utility. And so in our template, we use curly brace %, and then we're running a utility that's been plugged into the template system that is like when we're running the URL function, as it were, and we're going to pass a string to it, and that is within the route application, the view that is named second view. So that goes into this file, the route urls.py, reads down the views until it finds second view, and then it reverse generates the path that works for that. Now in this case, these two strings are going to be the same, and yes, that looks a little uglier, but the key is that we can make changes here, and this will not, the top one, route/second, will not reflect the changes, but if we're looking it up by name, we can do all kinds of crazy things and remap stuff quite naturally. And so again, it's just this URL command, the name of the view, the application, the view. So this is what it looks like when it's all said and done. There's no parameters to this. So if you take a look at this route second view ends up under this hard-coded, the route/second view, the hard-coded ones ends up under the string in the URL output, the page output. We just see it's /route/first is the thing that comes out from running the code URL and passing route:first view in, so that's what it looks up. And we can make a link. This is now an href, and the actual path is sitting there in the href. So now we're going to see how we do this when we're going from one application to another. So an application we're going to look at in just a bit is this thing called the generic views. It's an application called gview. And we want to make a link to that application, and we know that there are two views. There's a list view and a detail view. And all we have to do is go take a look at the urls.py, and we know that it's an application gview, and this view has a name and that view has a name. The view that is all the cats is got a name of cats, and the view for a single cat is cat. But the cat one takes a parameter. It's an integer number, which is cat number 42 or whatever. And so we're sitting here in the route application, main.html, and we can now go create a URL that actually is pointing to another application and a view within that other application. So this is a URL for gview cats, and that'll just look it up. So now we don't even have to know what the URL patterns are inside of gview/cats. Now, we can look at gview_cat, which is this URL, but you'll notice that this has a parameter, and so we actually have to add a second parameter, which is that 42 number. And so this will generate the URL straight to the detail page for a single cat. Now, there's a lot of nice stuff about this. So for example, if you omit this, it's going to look this gview_cat up and find it and say, you know what, I'm supposed to have an integer, and it'll blow up on you, right, if you get that wrong. Or if you put a 42 on this one, on the gview_cats, you're not supposed to have a number on that. But gview_cat, you are supposed to have a number. So this is one of the nice things about this reverse URL lookup, in that we can, there's some error checking that goes on, because if it could just blow up silently, and in many ways when code blows up silently, it's worse than blowing up in a spectacular fashion, because if it blows up in a spectacular fashion, you can fix it. And so this is what it looks like. So this gviewcats URL and gviewcat42, this one that actually is the detail page that demands a parameter, it constructs that just fine. Okay? So that's going from the route application to the gview application. Now, you can also, this is